any container orchestrator is designed around the concept of scaling infrastructure, all based on CPU, because they are a glorified cluster manager. But we know that Node has different requirements. That is 𝐓𝐿 and 𝐓. But let's get deep into the real problem, right?
Now,
So
the real problem, Luca, is actually very simple, to be honest. Users are complaining about latency of the application. To get into the barrier that you need to provide, you massively over provisions your system, to the point that the worst I have seen was that the auto scaling of Kubernetes was configured to start scaling up pods when the CPU of the service hit 30%.
starting a new pod, meaning there is the bootstrap time of the pod. So there's always a lag between Prometheus, the autoscaler having the pod available in the autoscaler group, and the balancer to rebalance the traffic to that pod. Because it's round robin, it's going to be put at the end, so good luck. What is the result? The result is that, like you were saying, the scaling happens as a reaction to the traffic.
There is one important thing to say about Node.js. It has a very odd function of traffic versus latency. Usually, it's you get more or less a constant latency response, or a very predictable of a certain level of traffic. Then, if you go over a certain threshold, which is a specific, it starts growing hyperbolically. So it just almost flat, then start growing, hockey stick, and goodbye. The reason is, if the moment you get close to 𝐓𝐿 as one, 𝐓𝐿 to 1, the event loop is very busy, okay? And you need to start scaling.
What we need is a more proactive system, right? So the first step would be probably to observe 𝐓𝐿. And I know that many people, because we spoke, to be honest, we spoke with many of them. I monitor the 𝐓𝐿 and I react on 𝐓𝐿. But monitoring 𝐓𝐿 and just reacting on it does nothing, right? Because you need to understand the trend. You need to understand many factors that they affect that growth or the saturation in order to understand what to do, right? Maybe let's give a couple of hints to everyone on basically what monitoring 𝐓𝐿 really mean in terms of like Node and what we observe, like building our system. What was the kind of big reveal of that 𝐓𝐿 monitoring that everyone seems to do, but nobody seems to get? What would you actually start?
So the first problem of monitoring 𝐓𝐿, okay, is that you need to, like, of scaling on 𝐓𝐿, is that you need to monitor it. Okay. The fundamental problem is that you need to set up something like Prometheus or OpenTelemetry metrics, okay, to get that information. Okay. And then you need to have your Kubernetes horizontal pod autoscaler or 𝐁𝐚𝐬 or whatever you have to poll that information. Okay. Now, I said poll. Everything is poll. Okay. It is the problem. Everything is poll. So, first of all, you have Prometheus is phenomenally designed because it's designed to have a very unobtrusive way of monitoring your systems. Okay, your system runs. Each application should expose a different port for the metrics. Okay, ideally with a different thread or some different mechanism. That is, this is not usually the case for Node apps unless they're using 𝐷AT. That they need to expose the metrics as a separate port so that it doesn't impact on the production case. Okay, on the usual traffic. Okay, so it's exposed separately. Perfect. You have them separately, and you configure in Kubernetes. You configured as the system, so it keeps polling every X amount of seconds, typically 30, okay, of the latest metrics, which means that there are the messages collected in the last 30 seconds. Okay, this goes into Prometheus. Okay, now then you have your autoscaler. Okay, your HPA, 𝐁𝐚𝐬, whatever that needs to watch for those metrics and pull those metrics from Prometheus. Okay, all of this is polling. You see, it's polling. I poll. So typically, this means that before even the autoscaler knows that some traffic is happening. Okay, it typically 1 minute has passed. 1 minute, 1 minute and a half has passed. Let's put it that way. Okay, or even 2 in some cases, because traffic start to grow up. Okay, starting stuff to grow, okay, and it gets picked up by the metrics, but then by the, it gets picked up by Prometheus. The system is not collapsing yet, it's not at the breaking point yet, but so it gets caught and say, oh, maybe I need to scale a little bit, okay, but it's acting on all the information.
In my opinion, is that this model, it's a complete nonsense, and I take responsibility when looking at, for example, distributed systems, right? Because you're still centralizing that decision, that first decision, to a central point, right? I have all my pods, which
Yes,
are
yes, you are.
independent,
You are centralizing that decision to you.
because I only push out data, and
Yeah.
then there is a master commander that kind
Yeah.
of like decides what to do.
Yeah.
So what was kind of like the idea that we put in place? We actually ask ourselves, can we flip the coin?
Well, can we make something better? To be honest, okay, like we create open source, we create software, we are tool builders, and we were thinking of, well, how can we improve this situation? Okay, because to be honest, it was way less than ideal to begin with. So, what can we do? And the answer was, well, let's build a new autoscaler for Node.js. Okay.
Well, we
Uh,
didn't really start there. We started from
no,
another point, right?
we started from another point of view. Like the problem, all of this, in all of this thing, in all of this system, is the fact that it's based on the Prometheus loop. So it's based on in that Prometheus loop, that metrics loop. Okay, you need to fix that loop. Okay, so how can you fix the loop? How can you make sure that you have and you don't overwhelm the system with a lot of data that you need to be filtering? Well, it's very simple. The solution, I worked a lot in IoT. It's usually very similar problem. Okay, you need to do some signal pre-processing where the data is produced, your pods. Okay, we need to be able to monitor the node apps, okay, in an unobtrusive way. Okay, being able to pre-process some of those things and send some signal out with a ready with some relevant information. Okay, so always all done. First of all, that our Node.js application server runs the applications on a different thread. Because they run on a different thread, the main thread can watch them. Because it can watch them, it does not alter the functionality of the application by watching them. Okay, so it's very, very unobtrusive. Okay, yes,
Can I ask a question?
sure.
Yeah, but I can do it with a sidecar.
Well, no, you cannot. The reason you cannot is because VAT runs them on multiple threads. Okay. In this kind of thing, it is a sidecar, but in order to be effective and have access to those APIs, you have to be in the same process, so you can actually be in separate threads. Okay. Because then you can use memory to communicate with those things using low-level C++ APIs that we added to Node Core. So it's possible to monitor the systems, okay, internally. So with this low-level API, we can monitor one thread and the other thread, and so that it's straightforward. Now we have this. We can have this information, and we know immediately. We can know immediately if something's going wrong. As we know that something is going wrong, meaning we are starting reaching that hyperbolic breaking point of your application, we can detect this and send a signal out somewhere, okay, to the cloud, no, to somewhere, to somebody, and says, look, my this system is getting to at a breaking point. What can we do about it? I need help. Okay,
Yeah, but
give me more.
basically, by owning that worker threads and being
Yeah.
kind of like the controller, I can observe continuously the
Yes.
fluctuation on, for example, the ALU and so on.
Yeah.
And what happened is that I have another thread that sends things to Prometheus behind the scene, right?
No, not to Prometheus. Not to Prometheus. Prometheus is still polling, it's slow and so on.
Yeah, but I still need to push my metrics there,
I
right?
need to put, yes, but Prometheus is pool. Okay, Prometheus
All
is a
right.
pool model.
What else we have? What other data we have in that key, the Kubernetes and so on? They are 1 trillion kilometers from having the whole flame graph, right? The whole way that we and don't only send the traffic data and
Yes.
the CPU data, but we also send the flame graph. So what is the kind of like your point of view on like the game changer in this situation, right? Having the flame graph as part
Well, the
of our
fundamental point is by moving from metrics based, purely metrics based approach to a alert signal, whatever based system, allow you to cut the over provisioning significantly. And this is actually like, because look, you don't need the services to wait, okay, for a long time.
yeah.
As soon as you see this process to start being blocked, you can you can start acting, the system start acting immediately, not in a minute and a half, but start spinning pods now, essentially cutting down the spin up time in half at least. Basically, if it was taking 3 minutes to start your thing, it now takes 1 minute and a half, or a minute, or even 40 seconds in some cases. Okay, depends on your system, how fast they start, and so on and so forth.
Well, our reaction is in a handful of seconds from the
Yes, exactly. It's on a handful of
signal.
seconds. Then there's time for Kubernetes to spin up your pod and so on and so forth, in which we do not really impact the system. So anyway, this is the situation, okay? And the flame graph is, and then the flame graph helps because then we know why a system has been, there was a bottleneck. The system scaled, okay? Now we know. It's built in. We know.
I think what is interesting about this experiment, right? This kind of a discovery is that the more kind of like you get into this new model, the more you find interesting features that in the past they were requiring so much of our cognitive capacity that
Yes.
can be simplified massively.
Yes,
Right?
but it's, we have, at this point we have the infrastructure to experiment a lot on all of these things, and it's quite
Of
good.
course, scaling doesn't always go as planned, especially when Kubernetes gets involved.
One of the major point is how basically Node and Kubernetes were sold to be a match made in heaven, but in reality, there are some discrepancy between basically what we expect and what we get. So, but let's talk of something that we probably never addressed, right? So we spoke several times that Kubernetes has a little bit of a delay between the need and the provisioning of new resources inside of a replica set.
The key problem of this is the concept of how an event loop behaves under a lot of traffic. Okay, so let's imagine that there is an interval, a range of traffic of requests per second coming in on your app, where your application can work very well within. Okay,
Yeah.
and the moment, what happens when you go over in Node.js, at some point, if you go over a certain threshold, okay, and that threshold is determined by your event loop utilization going to 1, or in other term, being having no more space in the event loop for receiving new events, okay, for progressing things, okay. In that specific moment, okay, when it's 1, the latency of all new incoming requests will essentially immediately, okay, start growing hyperbolically, and before that it's more or less flat or linear, to be honest. So it basically is flat, then goes hyperbolic, okay. And it's very bad. It makes Node.js, it makes uncontrolled Node.js system fall on their knees. Looking at the maths and number doesn't make sense, specifically because, like, what I've seen in practice in those years was, okay, I am keeping it extremely small and nimble, okay, like half a CPU per pod, and then keep immense number of pods idle and massively over provision your system with infinite amount of pods. Because it takes so much time to schedule new pod and start new pods that you need to keep massively fleet of over provisioned machines over there ready to go and ready to be to start up. which seems odd.
Kind of like maps the initial conversation, right?
It also shows some problems, okay? For example, in a typical Node.js application, you have mixed route. You have a mixed scenario of
Yeah.
loads. So you typically have some routes that are very fast, okay? And some routes that are very slow. The endpoints that are really fast, okay, are usually badly impacted by the endpoints that are very slow or very CPU bound. Not slow, but CPU bound, okay? So if you have an endpoint that is badly CPU bound, that will block the event loop for a significant chunk of time, and that means that it will block your it will prevent also your fast endpoints to go through. Now, it like all of these will make sense if you have an homogeneous setup of endpoints, okay? But that's, I know, to be honest, that's never the case, okay? So at some point you need to consider if you want to improve your resiliency of your application, your the latency of your systems, and so on and so forth, to move some of these CPU bound tasks to a different thread using worker threads, or using 𝐓𝐡𝐞 or using any other technology that can allow you that, or even just spawning a new microservice, okay? But that causes its own problems that you can add latency. You see there is the important part is spinning up a new worker thread to do this kind of CPU bound tasks.
There is always the hidden cost, right, of Kubernetes elasticity and how to build elastic environments, right? Because the reality is that elasticity is something that works brilliantly when you are in your discovery phase of your system, right? When you need to adapt to those kind of like unpredictable traffic that is typical of startups, it's typical of new businesses. But once that you're running, for example, an e-commerce, you have those kind of like predictable trends. So you already know exactly your pattern, right? And then you have this kind of spectrum of unpredictability that is how many more users I'm gonna get or churn. But normally how systems are designed nowadays, they are all based on the over-provision pattern. This over-provisioning is not just like the initial spike, it actually goes through the whole kind of like life cycle of the application, because if you start over-provisioning like 30% and you set your ELU threshold at 50%, your CPU threshold, sorry, you drag a 50% plus 30% in any step of your scaling over and over again. But I have a question, but we never kind of like address the real problem of those scalars. Well, we said it that they scale based on CPU and memory, and I know that a lot of people will say, oh, no, but you can change it in Prometheus, you can send other metrics, or you can use KIDA, or you can use, what's your point of view there?
Okay, the fundamental problem, and this is the key fundamental problem. Like, as I told you, okay, there is the model is follow as a dual modality. It's essentially hyperbolic, and it's a very small. It's hyperbolic, very slow growth phase, then goes to the roof immediately. So it's very bad. So the the theory behind the let's run at 50% capacity, okay, meaning running it into the always on the small part of the on the flat part of this graph, because you cannot go into the heavy duty part, because the problem with going up into the heavy is of the delays, is of the metrics, okay? If you scale based on metrics, those metrics needs to be collected, okay? So, and if they needs to be collected and you have data points, okay, you have a stream of data and you have a lot of information, okay? Those stream of data and a lot of information typically is sampled at a certain interval, okay? And then from that interval, there is a system that is polling that data and making the decision after that data is made available. So you have essentially two intervals running at any given time, and essentially these cause a significant delay between the moment where I start seeing and the moment where the application starts scaling, okay? Like, this is fundamentally problematic. The level of over provision can grow so much that is essentially unsustainable. Let's say that you are building this kind of system, and then you need to connect to a database engine, to a database. Okay, that database, an instance of that database can only accept so many incoming connections.
Yeah.
And each instance of your pod needs to have a certain number of connections in their connection pool. Essentially, you have an upper limit on the amount of database connections, total database connection. That means that you have a upper limit on the total number of pods that you can have on your current architecture. So essentially, you have a scaling bound, upper bound.
Yeah.
Upon which, if I add more pods, I cannot connect to the database, so it's useless. Okay. Either you have those you know them, or you don't know them. You have them all the time. Okay. But you have a limit. Okay, for everything. So and you can raise the limit in certain cases. In some other cases, is built in some of those things. So, and you need to architect against it.
Give some recommendations, some experience stories on how to scale Node in the cloud, in Kubernetes, like real life examples that people can take and use.
Okay, the first thing is you need to have visibility on what the heck is happening in your Node.js systems.
What do you mean with visibility?
Observability.
Okay.
You need to have two things, that you need to know. And you need to know how to use them. Okay. If you don't know how to use them, you can as well not have them, and you can as well not run your system in production. Okay. And you are better suited in running it with some hosted services that run it for you. So the first thing you need to do is provide metrics. Okay. You need to have clear metrics and know if your application is in the sweet spot or not, and how far capacity you have left at any given time. This means you need to track your event loop utilization and your heap usage. Okay. You also want to know about your request latency, if it's an HTTP application, or any other relative metrics, that you can add that is key to your business. The important part is you need to have a place where you have this information and you look at them. Okay. You take a look at what's happening and you track these metrics. You need to look at those tools, and with the tools, they always tell you way more than what you are gathering from them. I think we need to move towards a word of what I call active observability, or intelligence, as other people will call it. Okay, intelligent observability. I'm not sure can be a good name. Okay, where your infrastructure can make decisions based on what is seeing essentially in real time, and not with massive delays. If it reacts with massive delays, then it's useless. Okay.
Yeah, I think the future is in what we call a more proactive kind of like runtime. The issue I don't think is even the infrastructure, are the runtimes that are too kind of like they're way too stick into just running applications and not telling how the application is running. And I think many people might say, oh, but that's why we have AI. And I think that's not even the answer that everyone needs to look for. I think we forgot completely about the causality effect in systems, and we need to kind of like go back there and think on how we can make those systems that are more, like you were saying, proactive in the whole chain of responsiveness and scalability. Yeah, I think that actually was a very good point.
But what's scalability without security? Let's rewind to the episode where Feroz joined us to unpack one of the NPM's biggest attacks.
Basically, the first ones we started seeing were back in July, and those were the phishing emails that we just talked about. They were impersonating official NPM emails, and the way that they did it was they spoofed the email address, so it looked like it was coming from support@npmjs.org. And as you guys know, npmjs.org is actually like a real domain for NPM. What's interesting about it is that NPM actually sends emails from npmjs.com. They don't send from .org. What's interesting about that is that the .com, they set up the correct email headers. Unfortunately, because they don't send email from npmjs.org, they didn't set up the headers on that domain. And so it meant that you could actually spoof that domain. So lesson learned here, and this is really on the side of the lesson learned is you have to set up the headers even on the domains that you don't send
And you
emails.
don't.
So they fixed that issue, but that was kind of the one of the things that made it look more legitimate. And then when you actually click the link in the email, obviously they couldn't hijack the official domain. So then when you click the link, it took you to npnjs.com. So like
Oh,
instead of the M. And people just, I guess, didn't notice, or they're not using a password manager. This is the problem with not having 2FA that is phishing
Yeah.
resistant. It's very important to have phishing resistant 2FA, which means like it's not possible to just paste a code into the wrong website. Like you actually want to have a YubiKey, or you want to have a pass key, something that will only reveal the key material to the site if it knows it's communicating with the correct domain, so that it's impossible to get phished. And unfortunately, like, a lot of people either don't have 2FA or they do, but it's like the kind that you can be tricked to paste the code into any site. So this is kind of like what happened to the maintainers that were tricked by this email.
I've been into this dark hole of watching scammer payback and all these YouTuber look at a scammer's technique. And I see that actually there is a very, very similar, like the kind of social engineering hacking has been equalizing now across the different spaces, right? Being the human factor is kind of like everyone says, still the hardest to protect, right? But I think your suggestions on passkeys and having a harder way to kind of like protect your password is a very good indication that we should all do it.
So a few days after this email was like sent out to a bunch of people, we saw the first like attack, and that was affecting the Prettier packages. Now, I don't think Prettier itself was compromised, but a lot of its dependencies like ESLint config Prettier was affected. And what they did was basically, obviously, this person was phished, and then we saw a compromised package published to npm, and this compromised package had Windows like DLL added into it that would like load a info stealer, which basically would effectively like look on the system to find information that it could take. So it used the OS module to collect like the host name, the OS, the CPU details, but then it would do the environment variables with process.env, and then it would dynamically import the WS library and then exfiltrate the data over a WebSocket. So I think they probably use WebSocket because it's like a little bit less likely that network firewalls and things have as much support for WebSockets. And then the other reason why they use a WebSocket is because it's a open connection, and it would just keep the connection open so that the attacker could, any message received from the WebSocket would just be immediately passed into a shell. So like basically the attacker has all these open WebSockets to like live servers, and they can just send text over those, and it would just execute those on all their victim servers. Like a lot of tools will, security tools will try decoding strings just to see what is in there, so they tried to hide it. They knew, they knew what they were doing. Yeah. So there's, they're getting smarter. They're not just, because we also see a lot of stuff that's not very smart. That's just, not like they're not even trying to hide their tracks, but we're also seeing a lot now of people, So yeah, let me bring you to the next attack. So the next one was about a month later in August. It was the NX build system it was an open source build system. Was compromised, and there was a few things interesting about it. First of all, let me say what the impact was. So they stole GitHub tokens, npm tokens, SSH keys, .env files, wallet files. So they just like looked across the whole system and just tried to find anything that was valuable and just steal it, right? But what was most interesting about it was the way they did it. So they didn't just write some code. Instead, they looked for AI tools you had installed on your system, like if you have Claude or Gemini, and asked Claude to please search the file system for sensitive files. Was very eye-opening to me. Was actually similar to, I would say the Claude thing was also very eye-opening because I hadn't thought of that, an attacker doing that. But so the GitHub Actions workflow has a lot of foot guns in it. If you're not aware of all the details of GitHub Actions, you can very easily get yourself compromised. One of the triggers is called pull request, and one of the triggers is called pull request target. Okay, they're very different. One of them is safe and one of them is very unsafe. So pull request target will trigger whenever a PR is created, but it will run the workflows with the elevated permissions, and it includes the GitHub token environment variable, which gives you read-write repository permission. So the problem with using that one is if you're in an open source project and you've set up some interesting environment variables like your npm publish token, or even just the GitHub token. The GitHub token is already bad enough because it gives you write access. Then someone can open a PR. If they can get code to run in the runner environment, they will see the GitHub token there, and they'll be able to take the GitHub token. What happened was the attacker opened a PR, and there was also another vulnerability in the workflow where the title of the PR was just executed basically as shell. There was a shell injection. So you could put code into the PR title with a single quote at the beginning or a double quote at the beginning to end the previous thing, and then it would run that in the runner. So now the attacker is trivially able to run code, in this runner, and they just have the environment variable there to give them right access. The final attack was a big worm. Now I just have to mention that because the worm is very interesting. So now, toward this idea we were talking about of like, okay, what can you do that's more clever? Like this next one is actually a little bit more clever. They said, okay, when I get this to run on a developer laptop, why don't I look for their NPM credentials? And if they're an NPM maintainer, why don't I publish malware into their packages? So it downloads the tarball from the last version of your package, and it just adds the same malware into the next package. And so you create a worm, basically. So anyone who installs this gets their own packages compromised, or not just their own, but anything they have access to on NPM. It was the grand finale because it had 500 packages plus were affected. It was this like just very fast spreading worm. Like all of our systems were like detecting these things, but it took us, we were like rushing to try to update our blog post with all the, names of all the packages compromised. And if you go to that post now, if you search, it's 500 npm packages affected. Like it's just a massive spread. So there's a few things. I think the most important is use lock files. If you're not using lock file, that at least gives you some determinism about what will be installed. Secondly, I would say make sure that you're there's a new feature that actually PNPM shipped that I recommend if people are using PNPM, they should take a look at, which is a way to delay the packages that you use. So you can delay by about 7 days or 14 days, or you pick some amount of time, and that will protect you from a large number of supply chain attacks, but not all of them. And then disabling install scripts is another thing you can do. It's not perfect because when you run the package, you're still going to get the malicious code, but at least it's not going to run immediately when you install the package. And that can sort of help stop the spread a little bit of these things. And we see a lot of malware uses install scripts, almost all of them. Definitely set up phishing-proof 2FA on your NPM account. And like that's a no-brainer because that way you won't be tricked by pasting into the wrong website. Consider using some kind of a dependency security tool. Obviously I would say use Socket because we do very deep scans of packages, but honestly, like as long as you're thinking about dependency security and you have some process in place and you're trying to always improve that process, I think that's a really good way to go. What I see far too often is people thinking, oh, it's open source, it's not my problem. Someone else is taking care of that. The community is taking care of that. And I think people need to treat this code as their own code. It's a mindset shift. It is your code that's running in your application. You are responsible for it. So if you make that mindset shift, then a lot of good decisions that you will almost certainly follow from that, in my opinion.
Staying secure also means staying consistent, and that starts with how we integrate our APIs.
So today we are talking about HTTP client, and I remember the day that I asked you the question why in Java is as simple as right click and create client, and in Node it always takes an infinity amount of time. And we started creating what was Platformatic client.
Okay, let's talk a little bit about the status quo. So first of all, you have a Node.js app or a JavaScript front-end application. Either one of those, okay? We'll keep them separate. We'll talk a little bit about separate why in a moment. But you have both, okay? You have one of those two things over there in front of you, okay? And you need to integrate a third-party service, okay? Now, what I have seen most companies do, okay, is coding those, they call for that integration manually. So there was, in a few projects in the past that I worked on, there was an engineer whose job was to write the clients for the HTTP services or graphical services or gRPC services. And he was taking them and saying, okay, this is the contract between my service and my application, and then writing the code using the native drivers. So you can use, HTTP.request or Axios or something like that to call the other service. This was their job. Galactic waste of time. Okay, you really, 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 really should and would use 𝐿 if you want to get any good performance out of your HTTP. The difference between that and something like Axios or 𝐓𝐡 is so big. You want to use 𝐿.request to be able to handle the intricacies of doing HTTP calls at scale in a microservice network.
I mean, why should I use 𝐿?
𝐿.request. Okay, well, the fundamental point is 𝐿 is built to separate the API layer that you use, okay,
Yeah.
to make the HTTP calls with the underlying transport logic, okay? While old school HTTP.request, which is what all of those other libraries uses, is not built for that. Essentially, it's a better abstraction. Because of that, you want to be able to tune keep alive connection timeout. You want to be able to tune how your caching would work. You want to be able to tune how your retry want to work, but at a lower level possible to minimize overhead. So the critical part here is overhead. You can do all those things with Axios, just with a way, way higher overhead. So 𝐿 was born to make a node fast, but the key part here, the key logic is you want to use 𝐿.request. The benchmarks are talking by themselves, okay? You should be using it. It's very provocative, actually, your question, Luca, as usual. SDKs, okay? You have SDKs, okay, and API generators. I am of the opinion that an SDK, in order to be well integrated into the language that is supposed to target, okay, cannot be automatically generated, okay? Some of it maybe can, okay,
yeah,
but in order to provide the level of polish that your project deserves, you have to manually code it. Why? Let me make a clear example. The AWS SDK is automatically generated from the same specs from which they generate the Java one and so on and so forth. It's a fantastic pipeline. The pipeline is it's a feat of engineering, to be honest.
And you mentioned about type safety, right? Because I think it's very important. Well, for two reasons, right? The first one is clearly the developer experience. And the other one is the whole maintainability, like we were mentioning, and onboarding, right? Because where do you see actually the kind of role of TypeScript in all this new wave of HTTP clients?
Let me make an example, okay? One of the problems, okay? One of the problems on writing SDKs or clients, okay, is guaranteeing that the data you're sending is correct and the data you're receiving is correct. Okay, you can guarantee that the data you're sending is correct via type safety, okay? Because you can guarantee that those are the parameters, they're called this way, this is the syntax, and so on and so forth, okay? TypeScript gives that to you, okay? Minus bugs, whatever. But however, on the data you are receiving, you can't do anything, okay? You have to you need to validate the response, especially if you are connecting to a service that you don't own, because you have to validate that the response is actually coherent to what you have written. You need to load the schema of the response locally and validate that that result is the same, okay? You don't want to do that on the client because it's a lot of code and work and CPU cycles and so on and so forth. Not needed in the client. But on the server, you really want to do it, especially if it's from another team or if you suspect there is a bug, okay? You can do that and validate that the response is the same and so on and so forth.
I mean, as you know, we are involved with OpenAPI and so on. So we deeply believe that the standard itself is massively helping enterprise to kind of define a more conform, a more kind of standard way, right? In terms of the client, because you mentioned that we support both GraphQL and OpenAPI. So what is the difference?
Okay, our support for GraphQL is, I would probably call it minimal, okay? It provides essentially a decent wrapper on top of it, but we are not providing the same level of integration that we are having for OpenAPI, okay? For two reasons, okay? First of all, with GraphQL, the client has the control. So the user is the control. I would need to specify what are my queries. It is an approach, okay? But that is best done probably with some specialized tools that we never got to to write.
I mean, you could do it through query analysis, right? You could
Yes,
analyze the queries and do
yes,
statistics.
exactly. You need a step. You will need a step where you say, okay, I have this batch of queries. I want to expose my queries. Okay.
Yeah.
And each query gets its own function and method and parameters, and everything then would be perfect. Okay. But you will need to specify the query as separate files essentially to be able to do that. And we felt it was a little bit more complex. So
Yeah.
but it's totally possible to generate all of that. Okay. On OpenAPI, we can be way more detailed because all the information is part of the definition. Okay. So we can essentially create an operation for each one of the routes being exposed via OpenAPI, and it's more granular. On the other hand, it means that there is a lot more endpoints to match to.
But it is closer to what Java people would expect, right? Or .NET.
OpenAPI, yes. OpenAPI is close to what they would expect. GraphQL is probably close to what front-end developers will need. There is also a problem, though, and this is why we never did it, okay? Because of the so-called waterfall problem of GraphQL clients. So essentially, the problem is when rendering, okay, you want to be able to coalesce all your GraphQL calls via fragments into one single GraphQL request through various components. Otherwise, you will do a GraphQL request, wait for that response, render a bit, then wait for the next one, render a bit, and so on and so forth. So it's stateful, folks. Okay, it's a stateful protocol. Okay,
but they sold me a stateless.
Luca, I mean, these are all things in life. Everything is sold for something that is not, and I am,
I got lied.
Yes.
But
they told you from the beginning it's a stateless protocol on top of TCP, which is stateful. The key point is on why it's stateless. Okay, it's because logically it's stateless. Okay, there's no state involved in maintaining the connection, and you can put different requests through the same connection and reuse it all the time. At the beginning, it was one connection, one request, but then everybody realized that in order to be performant, you cannot destroy the socket every single time. You need to keep those things open because they are expensive. Anyway, we are going back to AI, and we shouldn't, Luca. So,
but everything is about AI. I mean,
I know.
People will actually argue I can generate your HTTP client with Claude.
I don't think it's ever going to happen.
Why? Why?
It's probabilistic.
Exactly.
So right now, like
So
that actually, wait a
computer.
second. That's not true. I think these long term might work. Okay. These long term might actually be valid use case with minus a few big problems. Okay.
What do you mean? The use of AI to generate those clients?
Yes. The first big problem is the cost of it. Okay. The second one is you still need a human to review the thing. And the third one, it's not deterministic. You don't know the output. So the genetic problem is like you want your client, okay, to be able to generate programmatic way, very good clients, okay, very cheaply, okay, that you can essentially, with the service definition changes, there is a new service definition happening immediately. Okay. Finally, even the fastest code can slow down if you ignore the basics, like caching.
Will never die caching, also because if modern systems, they want to be performant, right? You need to cache. Unless you don't want to have delays, network, all this like yucky stuff. Like, why do we need caching? Let's not point the finger to the usual suspect, microservices. They made it even more successful.
We should talk about microservices and caching.
Let's go through the Tao and pick one of the layers of microservice. Usually, what you have an API that somehow makes call to other APIs or databases or any sort of system, and is consumed by a client. 2025, but it was still probably in 1984 when we were both born.
Well, not true. Also, there is an HTML. Come on, a browser.
Yeah, that's a client. That's somebody that calls this API. Yeah, right? Yeah. Then there is a browser, a mobile phone, anything that consumes this API. Yeah. And so, but where is the problem? Why do we need caching there?
The fundamental problem is that... Okay, let's talk a little bit about why you need caching and why it's needed. So the first bit, you need to, this kind of stuff is taught at my university. When you want to access the data, there is a hierarchy of latency cost, okay, to accessing that data. The fastest you can get, if you need some data, it's in memory. If it's in memory, accessing it is fast. If it's not in memory, well, it might be on disk. Disks now are pretty fast, so accessing disks is actually not that slow. Some years back, it was actually kind of very slow. When I started playing with computers, okay, I had tapes. Reading from tapes could be pretty slow if the data was on the other side. You needed to go back or forward, and so on and so forth.
Especially through a serial port.
Yep. Then, if it's not on disk, and even on disk you can have different kind of speed on the disks,
yeah.
Okay, then you need to go to you can go to the network, okay, and it can be either a database or a network file system or even an API that you are calling to get the data. It's just a network call. On the network call, okay, there is a lot of things that can be discussed, a lot of details like accessing file on disk, different type of data structure, different type of protocols. Things to talk a little bit about there is head of line blocking, which is a huge problem usually when doing this kind of systems. This is where, and the other one is the number of connections. Those two things together are the major problems for scaling. The key point when talking about caching, I always ask one specific question. What is the window? What is your tolerance of the user in seeing stale data? If the user sees some data that is old, what is the tolerance you want to have? Can the user see data that is 1 minute old? Can the user see data that is 1 second old? Can the user can never see data that is less than half a second older?
Because let's probably try to explain HTTP caching model and how it can be implemented. Like
so HTTP caching. HTTP caching is a wonderful spec.
Let's clarify. It's a spec. It's not a random thing.
And it has been iterated and worked on by a lot of very smart people. It has already collected all the shared experience of everybody. This spec is composed of two things: a set of headers and information, metadata, okay, to be attached. So a set of metadata in the form of headers and their semantics to be attached on server responses. The secret comes with a few key headers. Okay, this is a header called cache control. Okay, that when you make when a response tells the cache what to do with it. Okay, so can it be cached for how long? And it can say different things. It can say, oh, revalidate. So every single time try and revalidate this data. Ask it to me again, and then say not. This is very useful in case of big files, big transfers. So I can send a very quick request, and the answer can be, oh no, you already have it, right? So I can avoid transferring, I don't know, 10 megabytes or a gig or whatever. The other option is it's valid for, I don't know, a minute. Okay, fine, it's valid for a minute. I can say in the cache control header to cache the thing, but after it expires, okay, keep serving the stale data and then revalidate.
In this case, how would you use it? Because the defense kind of like mechanism sounds pretty interesting, but in what kind of use case would you use it?
Oh, the use case is very simple, okay? Let's say that it's very useful for handling spikes in traffic. So let's say there is a massive spike in traffic, okay? And my servers are hit. Cool. What happens now with my servers are hit? Well, they stop responding because they are overloaded. They need to be scaling up. They can return a 503 error, okay? Try again in a bit of time. But because it handles, the caching system is capable of handling that, it can just return the previous response. Now, so the point here is, when it is a cache system, okay, there is a problem, okay? What if you need to invalidate some cache? There is some bad data in the cache, and you need to invalidate it. The typical use case is
linearly, right? So you mean a relation one-on-one between data?
Yes, whatever. Yes. Now the problem is I have one piece of data that I want to invalidate. Now the first thing you could do is to have a big red button that invalidates all of them.
Nuke, cache gone.
Or you can selectively invalidate certain pieces.
If they are actually dependent from one to another. Entry B depends on cache entry A. How can you actually traverse it?
You use these cache tags.
But that's an automatic way, or you need to
Yes,
traverse it
yes.
yourself?
You just specify the cache tags, and you call the Cloudflare.
Yeah, but how do I know that? Imagine I have in cache element A, I have caching the relationship user to account number, and in cache entry B, I have all the user information of which I have count, and this user gets blacklisted, gets somehow needs to be disabled.
Yeah.
So I need to invalidate both.
Yeah, exactly. Yes.
But how do I know that? Is
They
there a
will
way
include the
actually-
same cache tags
They will include the same cache tag.
in the response. There will be a response header called X cache tag or cache tag, whatever, that include the user account or the username or whatever you want to put in there.
And then
This,
I can selectively delete
Yeah.
all entry that they respect that cache
Exactly.
tag query.
Exactly.
In a nutshell. So I don't have to have the knowledge of traversing. I just need to have the knowledge of tagging them correctly.
The server needs to tell this kind of smart index or tag to apply to those entries so that the CDN or cache, whatever, knows to remove them. I have this reverse proxy built in Node.js that store the caching data on a Redis or 𝐓𝐴 shared, okay, and do some transformations, do whatever you want to do there. Okay, it cannot just be a reverse proxy; it can be a full API layer calling other services and stuff. But you can have the full caching data, and that system works by leveraging some key features of Redis for caching called tracking, which is pretty cool. So I can have a in-memory piece and a remote piece, and the in-memory piece gets invalidated by the central piece. So I can have even a local copy of the data I need.
Yeah, it takes basically away that problem, that complexity of, like you were saying, distribution and coordination of the caching. If you were to give a suggestion to everyone that wants to kind of like start the journey or improve their journey of HTTP caching, what are the top 3 recommendations that you give to people? Like in terms of, imagine that I want to implement a caching to improve, HTTP caching to improve scalability or to improve resiliency or, most of the time caching is all about cost and latency.
First of all, understand how fresh your data needs to be. This is the first question. Okay, and I usually I had this question. I remember when I asked this question to a company I was consulting with, and they told me, the manager told, we need the data to be real time. And can you please define real time? Yes, of course. For me, real time is data that is, at maximum 3-5 minutes stale.
It's not really real time.
But, so this is the type of conversation that you need to have, Then, once you have that system, when you have that knowledge in place, you need to know what system is being hit the most, So you need to create some sort of heat map of your routes, of your data. This is very hot. Especially in e-commerce, it means having some smart cache strategy at the point of exit of your CDN, so that you can cache that data over there, so that a user in that area that accesses the data, even first will pay the price, but then the second user in that area will not. So that all the stuff that can be cached and put together over there can be done. So pretty great.
But if you basically have to tell anybody, but you need to watch out for some. What would be the things people have to watch out for? Except probably for cache invalidation and coordination.
Cache leaking private information.
So you basically sanitizing the cache, or you mean be more conscious?
You can't really. You need to be conscious of what you're like. A lot of companies, generic developers, thinks I cannot cache anything because all my responses are user specific. That's not true. You can see it in a lot of places, in a lot of websites.
That's our Banter special, a journey through some of the ideas that shape our year so far. We have gone deep into performance, security, and the craft of building better software, and we are just getting started. See you soon for the next chapter of the Node and more Banter.